With IPv6 addressing, we have our network portion, which we call the prefix, and then we have a host portion, which we refer to as the interface ID. So how do we assign that interface ID portion, the latter 64 bits of our address? So remember, the prefix is typically going to be a /64, so how do we assign the latter 64 bits? Well, you can do it manually, meaning you could go to every single device and tell them this is your prefix and this is your interface ID. That's a lot of work. You could also have them just automatically come up with their own interface ID, which is what is commonly going to be done. And there's two different ways that can be accomplished. The first method that we commonly see being deployed nowadays is the random generation technique. So the random generation technique simply says this: I have just received notification that my prefix is whatever, so my first 64 bits. So now I'm going to randomly come up with a 64-bit network ID. How it's done doesn't matter right now. Okay, it doesn't matter how it's done because it's not deployed the same way on Windows devices as it is on Mac products, as it is on Linux products. So it's done differently. There's some hashing that goes on behind the scenes to come up with some random address and the random interface ID. However, that's just a temporary address, meaning that can be changed every so often. So it might actually change every day. It might change every 6 hours. It might change every hour. It all depends on that particular operating system deployment or what you have as security policies in your organization. Now, why do we have this random generation feature that is used nowadays instead of what was originally introduced? What was originally introduced was EUI 64, not used with end stations anymore nowadays. It's not. So why am I still talking about it? Because we use it still with our Cisco routers. Because our Cisco routers aren't typically connected to the internet. So it's not a big deal to continue using EUI 64. But for end stations that will be connected to the internet, for mobile devices that will be connected to the internet, I am not going to recommend anybody use EUI 64 anymore. The random generation technique is the way to go. Why is that? Well, with EUI 64, we use the MAC address of the device, of that particular interface. So if I'm using the MAC address of that particular device, and I am slightly modifying it, as we see here, we'll get into the modification very soon, but if I'm slightly modifying it to create a total of 64 bits, would it not be possible then to reverse what I've done here and come up with the MAC address? Well, of course. So we can see down here, the latter 64 bits end up being 029027FFFE17FC0F. This is an IEEE standard way of creating these latter 64 hexadecimal characters, or not 64, but the latter 64 bits, which represent these hexadecimal characters now for the interface portion. So I could work backwards from there and come up with the MAC address. Now, why would that be bad for a mobile device as an example? So here's the deal. I currently live in Eastern Canada. So I'm using my device here, using IPv6 to do my mobile device. Right now I hop on a plane and I'm in Toronto using my mobile device. Could I be tracked based on my MAC address? Yeah, I could be tracked, couldn't I? Yes. So now I end up in Chicago. I'm in the airport. I connect in the airport. Can they track me? You bet they can. Based on my MAC address. They now know I was in Eastern Canada, then I was in Toronto, then I'm in Chicago, now I'm in Phoenix, Arizona. I can easily be tracked based on my MAC address because MAC addresses are associated with the interface of that particular product. So that is going to follow me everywhere I go. And as a result, everybody just based on my now IPv6 address knows and can follow me everywhere I go. Easy to track people. So that is now a privacy concern in regards to mobile devices, in regards to PCs, and so on and so forth. So Microsoft, with the Windows operating systems, Linux operating systems, Mac operating systems, mobile device operating systems, all that. They are not using EUI64 anymore. They're going with the random generation technique, because the random generation technique is going to come up with just some random value. And every time you connect to an IPv6 network, you're going to get a new random value. So it's almost impossible to track somebody successfully around the world based on their MAC address now, because you're not using the MAC address. Or in some cases, the MAC address is being used, but there's a hash mechanism that goes involved, and then whatever the output is what is used. So that would be hard to reverse engineer. All right. So regardless of how that random generation technique's working, I do want you to know how EUI64 is being utilized, because we see this used with our link local addressing on our routers. And also we can use it with global addressing on our routers if we so choose to, and our unique local addressing as well. So here's what happens. We take the MAC address and we break it in half. That's right, break it in half, right down the middle. And we fill the field with fluff every time. I didn't come up with that. Fellow student of mine once said, hey, looks like we're filling the field with fluff every time. I'm like, you got it. That's the best way to describe that. FFFE. You just throw that in there. So now we have a new 64-bit address, whereas before the MAC address was only 48 bits long. That's why we're filling the field with fluff every time, FFFE, to make it 64 bits long. That's why. So now that that's in there, we still need to do what is known as flipping a bit. Flipping a bit.